All right, here we go. Unit 2, Day 2, Polynomial Long Division. So today we're going to learn how to divide these long variable expressions the same way we would numbers. It's going to look a lot like regular long division, which it may have been a while since you've done, so let's do a quick refresher. If I wanted to divide 1573, if I wanted to divide that by 13, long division is a little bit of a trick that's sort of just hiding some mental math from you. But it is a nice way to just make the progression to polynomial long division. The way we usually do regular long division is we start to say, okay, what is the first chunk I can fit a 13 into? So we look at the 1. We can't fit a 13 into a 1, so we move to the next pair. 15. We can fit 13 into a 15 specifically one time. Now, that 1 is going to end up meaning a 100, and basically we're just going by hundreds, then tens, then ones places. But anyway, 1 times 13 is 13. Really, that means 1300. We subtract this, we're left with 2, and we bring down the 7 and the 3. See how that really tells us there's 273 left over once you've done 100 13s. So now we need to figure out, okay, how many 13s in multiples of 10 can we do? So we look to 2, can't fit 13 in there. We look to 7, yes we can, into 27. We can fit 2 13s into 27 because 2 times 13 is 26. Again, if you're really following what's going on here, that means 20 times 13 is 260. But we subtract these, we get 13. Well, all we're left with is one more 13 left over. So we have 100 13s, then 20 more, then one more. That gives us a remainder of 0 because this divided evenly. The answer here is 121. The same process is going to take place for polynomials. So I'm going to put my dividend, we'll focus on these vocab terms in just a second, but you'll just get a taste of them now. I want you to just see a clean example here. The dividend, what we are dividing into, x cubed plus 5x squared plus 7x plus 3. And we are going to divide that by what we are going to refer to as the divisor, what you are dividing by. And our result, we're going to call the quotient. That's probably the most important term, so I'll start writing it here. The quotient, or the answer, is going to appear on top, just like 121 was the answer to 1573 divided by 13. We're going to go term by term, and we're going to think about what could I put here so that when I multiply it by x plus 3, meaning multiply it by both the x and the 3 via distribution, what would give me, and you can kind of pre-write these down here if you want, what would give me x to the third? And the answer here is that would be an x squared. And so let's just really carefully think about why. Follow those arrows. X squared times x gives me the x to the third. Now I also have to do the other part. X squared times 3, we have to do the plus 3x squared here. You have to finish it off. And now, like in regular long division, we subtract what we have here. The x to the thirds cancel, and when we subtract 5 minus 3, we have 2x squared plus 7x plus 3 when we bring these last components down. Take a look at that, because if you can do that, you can do the entire thing, because now it's just repeating the process. But now I'm asking myself, what could I multiply? What could I multiply again by x? What could I multiply by x plus 3 to give me 2x squared? So the goal is to make 2x squared down here. Sometimes I like to just rewrite it there right from the get-go. And it's going to be a positive 2x. 2x times x is 2x squared. You also have to do it times the plus 3. So 2x times plus 3 would be plus 6x. Last step, we subtract. The 2x squareds cancel. 7x minus 6x, we're subtracting here, is 1x plus 3. I know I've done my job correctly here because I wasn't left with a remainder. Now you can get a remainder, that can happen. I'll tell you though when that happens. I like to give the first day's assignment on this with no remainders, so these problems are kind of self-checking. If you get a remainder, if your last thing doesn't also give you 1x plus 3, you'll know you've gone wrong here. Your check for now will be that you wind up with no remainder. And so this is just generally how this works. I'm going to show you one example. We're going to go straight into what the hardest example you could possibly see is. So you can see a couple of common pitfalls, and you just see everything at once, step by step. What this is going to look like is when we find the answer. So we are trying to find the quotient. This will be the quotient to 16x to the fifth minus 10x cubed minus 8x squared minus 6x plus 8. Now, the really important idea here, and I need to write this as a note here, you need to use zeros for missing terms. And what I mean by missing, this is super important, and I forget to do it all the time, and it frustrates me, and it's going to frustrate you the first couple of times. You need to have, to set this up so that everything lines up nice and cleanly, you have to insert missing x terms. So notice how we go x to the fifth, then x to the third, then x squared, then x, then 8. In order for everything to line up nice and neat, it's not impossible to do it without doing this, but trust me, this makes your life way easier. I'm going to put a plus 0x to the fourth in here to make everything line up. And I'm also going to do that for my divisor. See how our divisor goes x squared and then there's no x term? I'm also going to do a 0x to the first term here. And so you're going to see why it's going to make everything just line up nice and neat when we do this. We're going to set up, I'm going to set up a pretty long division sign here. Our dividend in black is going to be 16x to the fifth plus 0x to the fourth. Notice I'm putting that plus 0 in. Now we're back minus 10x to the third minus 8x squared minus 6x plus 8. And then we're going to divide this by our divisor. I'll do that in red. 2x squared plus 0x, you have to fill that in order to keep this nice and neat, minus 2. And like I said, they're not all going to be this bad. I'm showing you what the worst possible case could be, because it is so easy to forget to put those 0 terms. But once you have this set up, this will work the same way every time. It's just a matter of practicing it a few times. So here we go. The first thing I want is a term that will multiply by 2x squared to give me, and actually let's do the arrow like this so you can see really what's going on here, by 2x squared to give me 16x to the fifth. I like to think of the numbers first. I need 2 to get to 16, so that's going to be 8. And then I need to get from x squared, I need to build that up to x to the fifth. So I need 3 more x's that are multiplying. I need 8x to the third. 8 times 2 is 16. X squared times x to the third. We add their exponents, x to the fifth power. So we have 8x to the third. Now we also multiply it by these other two pieces. Just like distribution, you have to multiply it. So 8x to the third times 0x, you get 0x to the fourth. Notice how this keeps us all nice and lined up. 8x to the third times negative 2 is negative 16x to the third. And so when we do it this way, everything's going to line up. 16x to the fifth, we're going to subtract the result. So we've filled it in, we've multiplied our quotient term by the divisor, and we're going to subtract the result. 16x to the fifth minus 16x to the fifth, gone. 0x to the fourth minus 0x to the fourth, gone. Negative 10x to the third minus negative 16x to the third. I'll write this up here. Negative 10 minus negative 16. That's negative 10 plus 16. That's going to be positive 6. make use of your calculator at home if you're having trouble with these negatives and positive, that's fine. But it's negative 10 minus negative 16x to the third. This is positive 6x to the third minus 8x squared minus 6x plus 8. All right, here we go. Need to repeat this process. Now, I need a second term here that when we multiply it, again, first by the 2x squared, and then we'll do the other pieces, gets me 6x to the third. Okay, well, that's going to be, I need to get from something times 2 is 6. That's going to be 3. And then I need to get from x squared to x to the third, I need one more here. I need a 3x, so I need plus 3x. So let's see what happens here. 3x times 2x squared. There's my 6x to the third. Now I do my other 2, right? I multiply by the 0 and I multiply, we're running out of room to write arrows here, but you get the idea. I multiply by my 0x. That's going to give me plus 0x squared. And then I'm going to do 3x times negative 2. That's going to be minus 6x. Okay, this is interesting here, what's about to happen. 6x to the third minus 6x to the third, canceled. Negative 8x squared minus 0x squared, well, it's not doing anything. It's still going to be negative 8x squared. Negative 6x minus negative 6x, anything minus itself, is gone. So we have 8x squared. I'll fill this in plus 0x just so we can keep track, plus 8. I like to make sure that there's, notice the first one goes 5, 4, 3. Then we go 3, 2, 1. Now we go 2, 1, 0 there in terms of exponents. Now we have to just do this last term. What do I multiply? What do I multiply by 2x squared to make negative 8x squared minus 4. Negative 4 times 2x squared is negative 8x squared. Negative 4 times 0x plus 0x. Negative 4 times negative 2 plus 8. So this all works out like we would have wanted it to. Each of these will cancel. Negative 8x squareds will cancel. 0x's will cancel. 8's will cancel. We have a remainder of 0 here. So our quotient, our final answer, is 8x cubed plus 3x minus 4. That is truly, how do I hide here? That is truly as awful as these examples get. That had everything. That had missing terms in the numerator, missing terms in the denominator. So to kind of calm you down so you don't like freak out about this, you may not even see one ever that hard. Here are just 2 quick examples of what this would look like with some more reasonable ones. So real quick final answer. I just want to do this real time here so you can see this, hear my thought process. If I'm dividing 6n squared minus 4n minus 16, and I'm dividing that by n minus 2. The first thing I'm going to do is I'm going to fill in, okay, what times n minus 2 would give me 6n squared? 6n times n squared would give me 6n squared. 6n times negative 2 would give me minus 12n. I'm going to subtract what I have here. The 6n squareds would cancel. Negative 4 minus negative 12. That's negative 4 plus 12. That's going to be 8n and bring down the minus 16. What times n would be 8n? Just the number 8. 8 times n, 8n minus 16. See what I'm talking about? That's a much more typical example of what you might come across. N minus 2 times 6n plus 8 is going to be 6n squared minus 4n minus 16. We're just undoing multiplication. One last one, just because it's a classic, and I want you to see sort of an example that has a couple of missing 0 terms. We're missing a 0x squared, and we're also missing a 0x here. Just one final example here. I'm still going to get in here under 16 minutes, it looks like. If we do x to the third plus 0x squared plus 0x minus 1, there's no missing terms from our divisor, x minus 1. And so if we go through and we say, okay, what times x is x to the third? This first term has to be an x squared. We multiply it out. X squared times x is x to the third. x squared times negative 1 minus x squared. We subtract these. The x to the thirds cancel. 0x squared minus x squared, sorry, minus negative x squared. Now we have positive x squared. And we bring everything else down. Plus 0x minus 1. Now we do what times x would be x squared. This is going to be plus x. Once again, we multiply by each part of our divisor. X times x is x squared. X times negative 1 minus x. We subtract. The x squareds cancel. 0 minus negative x is going to be positive x, and we bring down the minus 1. Here we can see this all worked out because if I do plus 1 here and I multiply by each of those terms, we'd have x minus 1. So our final answer here, the answer to this question, x squared plus x plus 1.